All right, now let's look at what happens when we have a situation where we're bigger on the top. Bigger on the top is when we say no horizontal asymptote. But what that does not mean is it doesn't have an asymptote at all. They always will. It's just it'll be what's called oblique. So this could be a diagonal like this, a diagonal line. It could be like a parabola. What you do is you just simply divide the two equations from one another. What you're left up with, this function, is what the asymptote will look like. Rather than trying to explain it from the words, let me just show you an equation here. So let's go through here. When we would start, we'd say the vertical asymptote is, we'd take the denominator, set it equals 0, and we'd say we're going to have one at x equals -3. And then we'd move on to the horizontal asymptote, and we would say that this is the rule bottom, bigger on top, because the power on the top is bigger. 2 is bigger than 1, so there's no horizontal asymptote. Now, that doesn't mean that there's no diagonal asymptote of some type. So here's what we can do to find out where the asymptote would be, the oblique asymptote. What I'm going to do is I'll write this out so you know what I'm doing. Oblique asymptote. It'll be found by using division. I'm going to use synthetic division. Since we know that x equals -3, that's what we're dividing by, I'm going to divide -3 into the values from the top, which would be 1, 1, and -8. You could use long division if you wanted. I'm just going to use synthetic. All right, so the 1 comes down, and 1 times -3 is -3. This comes down, becomes -2. We times that by -3, we get 6, and we'll have a remainder of -2. Now, we should always have a remainder. If not, it's a whole. So this is my remainder. What this means is my oblique asymptote. The oblique asymptote is going to be y equals x minus 2. The remainder won't make a difference on this graph. And let me real quick find the intercepts, and then I'll show you the picture, which I know you can see your picture on your copy of the notes. But the intercepts we would find by setting the top equal to 0. So we'd say x squared plus x minus 8 equals 0. We would try to factor this, and we're going to run into problems because I don't know of any factors of -8 that add up to 1. Yeah, we're going to run into trouble here. So it won't be any whole numbers or integers. Let's see what they come up with here. It looks like there's a fraction there. The things that I can see real easily is that we do have this at x equals -3. They're counting by 2's here. That would be -2. This is -4. You can see that would be at -3. And this asymptote, again, they're counting by 2's. It is y equals x minus 2. Exactly what I came up with. If we did the quadratic formula, we could find out what our asymptotes are, or excuse me, our intercept is. So I'll just use quadratic formula. Or you could graph and do menu analyze and choose zeros to find those spots. All right, but I'm not going to worry about that on this lesson here. You try and see if you can come up with a oblique asymptote on this one.